All right, guys, today for 10.5, we're actually going to focus on just recursion here. Iteration, we won't worry about this time. So we're just going to look at objective 1, which is recognize and use special sequences using recursion. So really quick, guys, the difference between recursive and explicit formulas, if you haven't figured it out yet, is that a recursive formula depends on the previous term, whereas an explicit formula does not. Okay, so this one means like, I take the previous term and I do something to it. That's a recursive formula, and that's what we're going to focus on today. So, two types of recursive formulas. We have the arithmetic sequence recursive formula and the geometric sequence formula. So for the arithmetic sequence, we're always just taking the previous term and we're adding the common difference. In other words, if I had 2, 4, 6, 8, the common difference here is 2, right? So I could take 2, add it to the previous term, and if I did that, in this case, I would get a 10 for my next term. Right? For my geometric, it's taking the common ratio between things. So that's like if you're multiplying by a common thing, like 2, 4, looks like it's going to go the same, but it's not. 4 times 2 is 8, 8 times 2 is 16. If I had something like this, the common ratio between each one is 2. Okay, so to find my next one, it would be the previous term, 16 times 2. 16 times 2 gives you 32, and that's how you would find that with a geometric. Okay, that's called the common ratio. So example 1 says find the first 5 terms of the sequence in which a1 is 8 and a sub n plus 1 is equal to negative 3 times an plus 6. Okay, so what this is saying is if you wanted to find the first 5 terms of the sequence, we're just going to plug in 1, 2, 3, 4, and 5. Okay, so if you plug in a 1 here, notice what happens. You get a sub 1 plus 1. That means that if you plug a 1 in, we're actually looking at the second term because we already have the first one. Okay, is equal to negative 3 a sub 1. Notice I plugged a 1 in for n here, right? So I'm plugging a 1 in for this little subscript n plus 6. Okay, well, I know what a sub 1 is. That was given to me. So I'm going to plug it in. So a sub 2 is equal to negative 3 times a sub 1, which is 8, plus 6. If I do that, I get, this comes out to negative 24. Negative 24 plus 6 gives you negative 18. Okay, so a sub 2 is equal to negative 18. We know that a sub 1 we already know that's equal to 8, so we have 8. The first 5 terms would be, let's do this, 8, negative 18. Okay, to find my next one, I'm going to plug in negative 18, because that's kind of how the pattern goes, right? So to find a sub, if I plug a 2 in next time for n, this would be a sub 3, right? Is equal to negative 3 times a sub 2 plus 6. We already know what a sub 2 is. We just found that. It's negative 18. So negative 3 times negative 18 plus 6. When you do that out on your calculator, you should be getting a 60. So we have 60 up here. Then we plug that back in. A sub 4 is equal to negative 3 times 60 plus 6, which comes out to negative 174. Plug that back in, and I get my final term, a sub 5, which is equal to negative 3 times negative 174 plus 6, which is equal to 528. Okay, so you're just basically taking your previous thing, plugging it back into the equation, and then solving. So that's example 1. They want you to find the first 5 terms of a sequence. All right. Now, we need to get a couple things in our notes here about writing recursive formulas. First of all, we need to determine if the pattern is arithmetic or geometric. Then we find either the common difference or the common ratio, and then we write our formula. Okay, we already went over what the formulas were, so let's try one out here. And here, for example 2, I'm not making you do any of these, but we know that this is a sub 1. And then here we know that there's not a difference of 12 happening, right? If I add 8 to 12, I would get 20. But if I add 20 to 12, I don't get 50, right? So something else is going on here. There's actually 2 things going on here. And it really depends on, where your first term is. So if you continue down the pattern, it really helps you identify what that thing is. But again, I'm not going to make you do this on the test or the quiz. So if you're interested in learning how to do this, I will go over it with you, but I'm not going to spend a lot of time on it here. Because what I really want you to be able to do is to use a recursive formula. So example 3, this is something that you could all use on a future budget, perhaps, or something related. So this says, write a recursive formula for a $10,000 debt. Hopefully you don't ever have that, but $10,000 debt, maybe it's a mortgage, I guess, or a car, but hopefully you're not doing that either. But anyway, $10,000 debt, 2.5% interest, which is actually kind of what a home loan is right now, actually. I think that's what my interest payment is, with a $600 monthly payment. Then find the first 5 balances. Okay, so for this guy, we know that this interest is per, actually, you know what, I have a 2.5 per year. This one's per month, so this is actually kind of high. But 2.5% interest per month. Okay, so since it's per month, they made it kind of easy for us. What I'm going to do is, if I wanted to know what my, if I didn't make a payment and I wanted to know what the next one was, if there was no payment made, just to be clear about this, then the next month we'd have the $10,000 principal. We have to multiply that by 1.025. Okay, and if you do that, that would give you your new debt, assuming you didn't make a payment. But we are making a payment, right? So what we have to do here is we have to say, okay, we're going to multiply the previous balance by 1.025. That'll give us our new balance, but then we also have to, at the same time, subtract our payment, right? So let's try this out. For our first month, month 1, I know that I have a $10,000 bill, right? $10,000 debt. Okay, month 2 comes around. So I have to take my $10,000, multiply it by my 1.025, and then subtract 600. Okay, so if we do that, let me just do this on my calculator here really quick. I encourage you to do the same. 10,000 times 1.025 gives me 10,250. And then I got to subtract 600. So if I subtract 600, which is my payment, now I have a balance of $9,650. Okay, so to find my next one, and you can actually program like an Excel sheet or something like this to do these calculations for you. You put the calculation in once, and then pull drag that cell down, and this will tell you your payments for the whole life of the loan. So if you just know this basic math, you can do that. Very simple. So month 2, at the end of month 2, we have a $9,650 balance. Then I would plug that back in. So I take $9,650 as my new principal, multiply it by the interest rate that I'm getting charged, subtract 600, and when you do this, you should be getting approximately $9,291.25. Okay, so then that's your new balance, $9291.25. You're going to plug that back in, and you're going to keep going. Okay, so I'll let you finish. All right, so pause the video there. The next 2 that you should be getting is 8,923.53 and then 8,546.62. Okay, those are the first 5 balances using your recursive formula on this debt. So you have a couple of examples in the homework related to that. All right, guys, that's it. I will get that homework sheet to you, and we'll do a couple of these in class. We'll catch you guys next time.